Hello and welcome. Let's finish section 3, part C, on quadratic functions or equations. So the main goal is to solve a quadratic function by completing the square today. So just a reminder, quadratic functions have this form of f of x is ax squared plus bx plus c, where a, b, and c are constant real numbers and a is not equal to 0. So let's talk about what completing the square is. These are the steps. We're firstly going to have this set equal to 0. So whatever it is, ax squared plus bx plus c, we have to have it equal to 0. So move everything to one side and have it equal to 0. When you do the next part, secondly, we'll actually move that constant term c to the other side. So whatever that value is, if it was 7 or negative 7, we add or we actually subtract it to the other side. Once you do that, we're just going to assume that a is 1 for now. It gets a little bit more difficult if a is not 1. We'll talk about that at the end. So let's just assume a is 1 for convenience sake. So we got rid of the a and have it this here. And then what we're going to do is we're going to take b, that value, divide it by 2, and square it, and we're going to add this to both sides. So let's go to the next page to show that. So that should look like this. Again, thirdly, we added this to both sides. So we'd have this added to the left side and this to the right side of the equation. Then this actually factors into x minus b over 2 times x minus b over 2. Because this is squared, this is squared. So in this case, we have x minus b over 2 all squared. And then we have minus c plus b over 2 squared. Now this is just going to be a number. And then we have this. So the nice thing about this, if it's in this form, we can square root both sides of the equation. And essentially, we're done with finding our answer there. And let's go ahead and walk through those steps here just to show that, because sometimes showing kind of a formula or algorithm doesn't always help. So before we walk through everything, we're just going to complete the square. What am I adding to this right here to complete the square? Again, w squared minus 6w plus what number would make a perfect square? So what we're looking for is b divided by 2, that quantity squared. So if I think about that, in this case, our b is negative 6, all divided by 2, that quantity squared, which is equal to negative 3 all squared. I like to write it this way because this is actually my b over 2 here, and that'll be very useful in a little bit, but this ends up simplifying to 9. Negative 3 times negative 3 is 9. If you're typing it in a calculator, make sure you're using parentheses around the negative 3, because anytime you square a real number, it will always be positive. So this answer should always be a plus number here, which in this case is this plus 9. So just walking through that again, what would this value be? Again, we take 18, the b value, we divide it by 2, and we square it, which in this case is 9, the quantity squared, which is in fact 81. So we're going to be adding 81, and that would be to both sides in just a moment. So let's actually complete this square. Now the first thing we're going to do is we're going to actually write the form, which is that kind of that fourth step, and then we're going to solve that to get to our solutions. So let's look at this. In this case, I'm going to rewrite this. So I'm going to have x squared minus 10x, and then I'm going to subtract the 14 to both sides. So we're going to do step 1 here, and that is subtracting the constant to the other side, which moved it over. Now I leave space over here because I want to add to both sides. I want to add b divided by 2 squared to both sides. So again, this is b divided by 2 squared. What is that? Well, we're going to take this negative 10 divided by 2, and we're going to square it, which again is negative 5 squared, which turns out to be 25. So we're going to be adding a positive 25 to both sides. That is my thing. And now I am factoring this quadratic, but it is already kind of factored for us. It turns out to be that really easily because this is just x minus 5 squared. That minus 5 is very easy to find because it's right here. It's whatever b divided by 2 was, which is negative 10 divided by 2, which turns out to be negative 5. That will always be the case. This is always b divided by 2. So let me highlight that just to remind you, this right here will match this right here. Now the right side of this equation, you just have to simplify that. Negative 14 and positive 25 give me 11. Now this is my form. So we're going to have minus 5 and then 11, and we'll click that. I think you have to actually click this button on our homework first, and then you can type it in. Now my solutions are, well, we have to square root both sides. If that square root property comes into play, we have to do positive and negative square root of 11 here. This turns into x minus 5 is plus or minus the square root of 11 here. The reason why is if we have something squared, this number inside could be a positive number or a negative number, because when we square it, it turns it always to positive. So it could have both a positive or a negative answer, hence why we have to do plus or minus. So let's move this up just a little bit. Because we're almost done, we just have to move this 5 to the other side. So x is equal to add 5 to both sides to get 5 plus minus the square root of 11. Now, I want you to write that as two answers, like 5 plus the square root of 11, comma, 5 minus the square root of 11. So that would be the way you would write your solution. So let's go ahead and solve this equation. The first step here is moving the constant to the other side. So I moved it over, so we have negative 47 over here. So I'm going to write that down. So step 1, we move the constant. So this is a step-by-step guide. So now that we do that, we're going to add. So now let's go ahead and add b divided by 2 squared to both sides, Now b divided by 2, so remember negative 14 divided by 2, and then square it, which ends up being 49. So we're going to be adding 49 to both sides. So I'm going to do this as a complete new step here. So we'll have x squared minus 14x, and then we're going to be adding a positive 49 here is equal to negative 47 and then plus this 49 here, just to show you that that step is there. So now what we can do is the next step is we're going to go ahead and rewrite it in that form. So we will write the left side as a perfect square. So that's kind of this next step is write the left side as a perfect square, which again, it's x minus b over 2. b over 2 was a negative 7. So, or sorry, it'd be x plus b over 2, which ends up being a minus 7. So x minus 2, the quantity squared, is equal to 2 here. Now we just square root both sides. So if we square root this side, square root this side, make sure it's plus or minus. So that'd be the next thing is square root, and that's both sides. Then we have x minus 7 is equal to plus or minus the square root of 2. And we just add 7 to both sides to get x is 7 plus or minus the square root of 2. And that would be my answers. 7 plus square root of 2, 7 minus square root of 2. Up here, without those square roots, is my form. So please try on your own. I will have answers shortly. So pause it. I will have some answers. So you should have got, this is the form, and these are the two answers. So that leads us to our last thing, which is what if A was not 1? And let's actually prove something cool. So if A was not 1, I'm going to move this up for us a little bit. And if A is not 1, the first step is still moving C to the other side. So we have ax squared plus bx is equal to negative c. You still move that first, but then we divide by a to both sides. So we're going to divide this by a, and then this by a. So if we do that, our new thing is x squared plus b over a times x is equal to negative c all over a. Now, we will still add b divided by 2 squared of both sides. But in this case, our b is in fact b over a. So if we think about that, this is equal to, when we think about b over 2, it's kind of a little trickier. It's going to be b over a, this case, all over 2, and then we're going to square that, which in this case, when we simplify this, we should get b squared all over 4a squared. So what happens is it squares this, which is b squared over a squared, and this is over 2 squared, which is 4. This is 4 over 1. We flip and multiply, so the 4 ends up going on the bottom. So we're adding this to both sides. So let's add this b squared over 4a squared to both sides. Now, if you think about this, we can write it in its factored form. This squared is equal to all of this junk over here, which is negative c over a plus b squared over 4a squared. What are we putting inside of here? Well, that is just b over 2a. So this is just plus b over 2a. Now, if you think about that, you can take this. Again, this is 2 divided by 1, and you flip it, so it ends up b over 2a. That comes into play. And if you remember that b over 2a thing, kind of looks like the axis of symmetry. What makes this 0 is negative b over 2a, where that axis of symmetry probably comes from. Wink, wink. So let's keep working here, and I'm going to move this up more and over a little bit. So now what we can do is we're going to square root both sides. So when you square root this side, square root this side, we get the plus or minus. We end up with having x plus b over 2a is equal to plus or minus the square root of something. Now, notice how we cannot put these fractions together because this is 4a squared on the denominator and this is a on the denominator. To make these the same, I need a 4 over here and another a. So I'm going to multiply this by 4a over 4a before I do that. So I'm going to multiply this by 4a and this by 4a. And that, if you remember, is 1. 4a divided by 4a is 1. And again, reason why I'm doing that is to make a common denominator. So this is minus 4ac. I put the letters alphabetical. And then plus this b squared. And now it's all over the same denominator of 4a squared. So this is really, really, really nice because I can simplify this a little bit. Let's rearrange some stuff. So I'm going to move my stuff up a little bit more. So if I do that, let's just write this as x plus b over 2a is equal to plus or minus the square root of, this is b squared minus 4ac. I'm going to rearrange this. Addition is commutative, so I can put that in front. And then if we think about what is the square root of 4, well, that's 2. And what is the square root of a squared? A squared is going to be a. So that's 2a. Now, if you look at that, we're just going to move this to the other side by subtraction. So in this case, let's subtract it to the other side. So it's negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Since they're both over 2a, well, we can combine the numerators. So let's just do that as our final thing. And we get x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which is your quadratic formula.